Here is the giant taxonomy of prompting techniques. Just with the prompt and no, let's think step by step with GPT-4o, it got 96 out of the 100 correct. And so I thought it'd be interesting to look at the 4 that it got wrong. Welcome everybody to Archive Dives with Oxen AI. Today, we're going to be switching it up a bit. In the past dives, we've gone deep into the underlying model architectures and techniques that make large language models work in the first place. This is a lot, in my mind, like studying the underlying CPU architecture of classical computers. It's great to know about registers, memory, clock cycles, logic units, but at the end of the day, we have to write high-level software to interact with these systems. And I think the same can be said for AI. In past dives, we've gone deep into how neural networks work, transformers, residual streams, and how they affect the next token prediction. And this can all be a useful mental model for what these systems can and cannot do. But at the end of the day, we need to use these systems to solve real-world problems. So we will be going into prompt engineering today, and not just how the neural networks work under the hood, but there's this really nice paper called the Prompt Report, which was a systematic survey of prompting techniques, and they go over 58, I think, different techniques, and they put them into a beautiful taxonomy. It's a really long paper, about 78 pages. Here is the giant taxonomy of prompting techniques that they put together. So I'll blow this up even larger because it's pretty small. So at a high level, there's 6 top level categories. So zero shot, few shot, thought generation, ensembling, self-criticism, and decomposition. And then within each one of those, they have different techniques that you can try. And so I thought there's been a lot of coverage on prompt engineering. I thought we'd go over as many as we can in the hour, but also try to run them on real world data sets. Because even in this paper, you can see this diagram of how they evaluated all of these. And they basically would take a full data set of things that they want to process, like tweets or sentences or paragraphs or whatever, run it through a prompt template, run it through a model, and then score it somehow. So we're going to go through a lot of these techniques live today and compare them side by side as we're going through the paper. So let's start with the basics. What is a prompt? A prompt is simply an input to generative AI model that will help guide its output. So they go over some pretty basic examples at the start of the paper. Everything from write a single paragraph email for a marketing campaign for an accounting firm. So this could save you some time writing emails, or maybe you're building some sort of customer service chatbot and you want to classify, well, in this case, it's not customer service, but maybe more of a Alexa style use case. And you want to classify what the user's intent is when they say event reminder, Mona Tuesday, or put in a increase the brightness of lights. And you might have some labeled data of what actions you expect it to do, and then you have the predictions of the model, and you might want to prompt engineer your way out of this problem instead of just training a model end to end. Prompting isn't limited to just large language models either. They talk a bit about vision language models. So you might have a model like Lava, and you can give it a prompt like list all the items in the scene in a comma separated list. In this case, I put a picture of Nikola Jokic and a horse, and you can see Lava kind of rambled on here and listed a ton of things and repeated itself over and over again. So it's not always perfect, but that's why we need to learn to prompt engineer. And the first kind of question that always comes up is like, should I fine tune or should I prompt? And I like to think of it as you should always start with prompting, but it's the same flow regardless of if you're prompting or training a model. So you want to do the same machine learning flow of collect a data set, split it into train and test. In a traditional machine learning sense, you're going to actually train a model here, and then you want to evaluate the model on results, look at the results. If they all look good, maybe we can deploy to production. But in a traditional machine learning sense, this step right here could take hours or days. So prompting speeds up this iteration cycle significantly. All you have to do is tweak your little text prompt and then evaluate it on a new set, look at the results, and you prove you can deploy that prompt to production. So it speeds up the process a lot. And although it feels really easy just to like try your prompt in a playground and then go and deploy it, all of these outputs from the system are non-deterministic and they might not be correct 100% of the time. And if you're newer to AI, maybe a software engineer by training, this can be a little unnerving, and getting into a flow of being able to test your prompt on a larger set of data, get some sort of accuracy out, is the best way to have confidence in your prompts as well. And to describe this a little further, often you don't just have one prompt that you're using to solve a problem in a pipeline. For example, if you're building a chatbot, you might even have different prompts for different stages within the pipeline. So you might be classifying intent, generating some SQL, doing some lookups, combining all of that into a response, and then responding to the user. And each one of these steps, if you don't have a pipeline that's evaluating the accuracy, the accuracy of the entire system kind of chains together. And if you have 90% here, 90% here, 90% here, and 90% here, you chain all of those probabilities together, and you might have like a 70% accuracy chatbot there. I know that math probably isn't 100% right, but you guys get the gist. So that all being said, we're going to take this taxonomy of 58 different prompts, and we're going to start with the 6 major categories and compare them on some real-world data sets. So zero shot, few shot, thought generation, decomposition, ensembling, and self-criticism. I went down a bit of a rabbit hole during the thought generation part of this, which I think will be really interesting to go over with everybody live. So we'll see if we get into decomposition, ensembling, and self-criticism. If not, happy to do it next week as well, but we only have an hour here. So let's see how far we get. So the first thing we need to wrap our minds around is prompt templates. So let's take the example of sentiment analysis, and we could have a simple prompt that says, classify this tweet as positive or negative, and then have this kind of string interpolation syntax, and you put the actual text here. So this could be useful to figure out how customers are talking about your product in the wild, or monitoring companies within the news to see if you want to make an investment in them, or even like advertising. You might want to advertise on sites that talk positively about the thing that you're advertising. And what's crazy is when I started my career like 10 years ago, we were an entire company built around sentiment analysis and other NLP tasks. And it would take us, months to collect the data, train the model, and just have one model that could do this specific job. And now it's as simple as just creating a prompt on top of a foundation model. So that's like the basic prompt template. And in this case, this is what they call a zero-shot prompt. So this is the first category that we're getting into. And zero-shot just means you're not giving it any examples of the input of sample data that you want to see the inputs and outputs of. And I don't want to say, I think there's a bunch of different zero prompt techniques. So they start with what they call role prompting. And this is like if you want to give the model some sort of persona, like act like Madonna or write like a science fiction writer. So for this example, I said rephrase the text as the lyrics to a Madonna song, put the text within the prompt template. And so this is like a financial tweet here, which we'll be using in later examples, but you can see the model translated that to a song and had like some nice rhyming and kept all of the information in there. So that's kind of like a more fun use case than like a one that you might use in a business context, but they talked about in the paper how even putting like a little bit of context of who the persona is before you try to solve the problem can improve accuracy as you're iterating on your prompts. The next one that they talk about is style prompting. So style prompting is used to get the model to either be more verbose or more concise, and has a little bit of overlap with role prompting, but I typically use it to make the model more concise. And for example, you might have that same prompt that we had above of classify the text into positive, negative, or neutral, and then you put the text there. And when you run that on a bunch of data, you'll see the model kind of rambles on and says like, the text is neutral and gives you some more information about it. The problem is if you're trying to compute like a pure accuracy from this model, and you might say, oh, I'm just going to do like a regex to see if neutral is in the response or not. If we look at this top level or this first example here, the model says neutral, positive, and negative all within this string. So it's really hard to tell if you were doing like some automated pipeline, whether or not the prediction was actually positive, negative, or neutral, if you're just doing a raw string match. So you can fix this with style prompting by simply telling the model to respond with a single word, all lowercase, and that same prompt there, you can now see the results are single word, lowercase, and we can easily match and compute the accuracy. I did this on a financial data set here, and I just did 100 examples just for the sake of time, and it got 89 correct with that simple prompt. The next category that they talk about within the paper is emotion prompting, which is pretty hilarious. So this is when you add a little more context to the prompt and say, think really hard about if it's positive or negative, and maybe add things like, my career depends on you getting it right. Or I've seen some hilarious examples on Twitter of like, my grandma's passed away and this is her final wish. So I took this data set right here and looked at, we got 11 wrong. And the ones that we got wrong were all in the neutral category. So I added this like, think really hard about it. If it's positive or negative, my career depends on it. And it bumped it to 91% on the 100 examples. I did a couple more iterations trying to add different combinations of like, my career depends on it, my grandma's sick, all this kind of stuff. And honestly, it was like 90%, 89, 91. Didn't really seem to have like a significant impact, but is fun in theory to think about how you can trick these things into being more accurate. So that's zero shot. A few techniques that are pretty simple. You've probably seen them out there before. Where it gets a little more interesting is this few shot prompting. So few shot is the process of prepending a few examples before the text that you actually want to predict. So in the sentiment case, you might have something that looks like this, where you give it this would be a 3-shot example. So you give it an example of a positive sentence, a negative sentence, and a neutral sentence. And then you give it the text, and then you would have to add something like this at the end so that it completes with just the next word after it. And the paper has some interesting categories to look out for while you're doing this. The one thing I'll caveat is I've seen this technique be more applicable to models that haven't been post-trained at all. When you use like a GPT-4 or a Gemini, they typically don't need you to do this preamble. But if you're just like grabbing a pre-trained language model off of Hugging Face and it hasn't been post-trained yet, this technique can help guide the output a lot better. And so the first thing that they talk about in the paper is just the pure quality of the examples. So in this case, they say, include as many examples as possible, and try to have like a diverse set of examples. So prefer to have 4 examples over 1, for example. They say that the example ordering matters a lot in their tests, which makes it makes a lot of sense if you think about the next word prediction. And if you have all of the angry categories at the top and all the happy ones at the top and all the angry at the bottom, it might think that's the pattern that it's trying to match in itself. And so the next one's just inherently going to be angry because it's like happy, happy, angry, angry, angry. So it's ideal just to like randomly shuffle the examples before you put it into the context window. The label distribution's also pretty important. So similar to traditional machine learning, if you put, 75% negative examples and 1 positive example, that could bias the model to wanting more negative than positive. So it's good to have like an even balance of the distribution in there. And then label quality was actually pretty interesting. I think those first 3 were pretty intuitive if you come from a machine learning background. But in this part of the paper, so they talked about how they did some studies with, especially with post-trained models in the few-shot examples, if you put the opposite label, the model will still perform the task as if it was the right label. And I think this is just because it's been trained for sentiment, for example, over and over again. So they caveated this with saying, yes, the label quality does matter, but sometimes the name of the label and the text itself, or sorry, just the text itself and like kind of the task you're giving it has more of an impact on the result set itself. So I did this for GPT-4o, and I gave it a 3-shot example of this one was supposed to be positive sentiment because profit improved. This one was supposed to be negative sentiment because sales went down. And then this one was still neutral. And so I gave it like a 3-shot example and asked it to complete. And the model surprisingly still got 88% accuracy on the regular sentiment task. And so I was thinking like, well, what if I was somebody who was trying to short the stock and I really wanted to flip it? So I decided to put a little, you are a financial analyst who sees bad market outcomes as good and good market outcomes as bad because you're trying to short companies. And then I put the end shot examples, and that bumped it up to like 95% accuracy on the reverse task. So it's not just the end shot examples themselves when you're using some models like GPT-4 that already have a lot of post-training done. Combining the techniques that we talked about before of like the role prompting, I'm a financial analyst, and some of the other prompting techniques with the end shot. So far, out of all these techniques, stacking all those together did get the best accuracy on this test.
So when 2025 is full of meme stocks, we can thank Greg.
Yes, exactly.
Glad to see that's the takeaway Mike gets from all this. It's true though.
I was going to say, I expect everybody to take this financial sentiment data set and prompt engineer their way on the weekend and just quit their jobs because they made so much money off sentiment analysis on the real market. So get back to me when you do that.
Do you have the results of just the prompt, the short?
Yes, I do. Let me show you guys how I kind of went through this process. So I've got this financial sentiment repository here. And we've been working on this cool evaluations feature where you can kind of like take any data set here, click run, and then type your prompt right here. And so I have like my whole history of the 3 prompts that I was trying here. So are you interested in just like the base style prompting, or which one in particular?
I don't recall you talking about results of just your like bad is good, good is bad with zero shot.
Oh, yeah, that's a good one. Let's just do that one live then. So let's take this test and let's take that Notion doc there, prompt report. And go here. So this one right here, right?
Yeah. Yeah, exactly.
All right. So this is going to take a little bit to run, but maybe we come back after
Yeah. Okay, great.
the
Thank you.
results are set. Yep. Prompt report. All right. Remind me to come back to that at the end. The next one that's interesting is the example format. And we've actually talked about this on a few past dives. So in past dives, we saw some papers reference that models are better at XML tasks than Markdown tasks because of the way that the pre-training data was crawled. Markdown usually gets rendered to HTML, and then the HTML is what's crawled, and there's been less Markdown kind of like in the pre-training data. But they say this is also the case for the end-shot examples that you're giving. So for example, like Q colon the thing, end line, A colon the thing, new line, is pretty common in the training data format. So they say like you're going to get better results if you do the text colon the category versus like the text equals the category. So you don't always know what's been in the pre-training data, but using XML or using patterns like this that it's seen over and over again seem to give better results than trying to kind of make up your own format in there. I just realized I just ran the sample here and we should run the full evaluation. Call this flipped. Cool. And then the final one for end shot that they say to look out for is the similarity of the examples. So always favor more diverse examples than similar examples. This is similar to if you were training or fine-tuning a model, but you should make sure that there are a bunch of diverse, and like the more the better. They did say there's kind of a threshold of like 20 shot seems to kind of flatten out. So if you have a pretty diverse sample set and 20 examples, they said that was a good rule of thumb, but I'm sure it depends on the models a lot as well. Some techniques that they talked about to select these few shot examples. The first one is just like using a K nearest neighbor search. And so you might have the user query that comes in, and then you could do an embeddings distance to find similar examples and their labels in like a labeled data set, and then populate that into the context window and use those as examples. Another one they mention is vote K, where you use one model to generate synthetic unlabeled examples, and then you use a human annotator just to label those things. And then that's kind of your few shot example. And then there's this one called self-generated in-context learning, where the model has to generate the labeled examples before you proceed. That one seems the least effective, in my opinion, because like it's only going to generate examples that it knows how to generate. So I would say K nearest neighbors or vote K are good kind of like programmatic ways to choose the examples rather than trying to hand choose these and put your own inherent biases into it. Let's go to this one and see if it's done. No, these do take a while because I'm using GPT-4. Oh. Okay, cool. So the next section, any more questions on like the few shot or zero thought shot? Those are typically the easiest ones to wrap your head around. Cool. The next category is thought generation. This one starts to get pretty interesting, and you might have seen this. One of the techniques within here is called chain of thought reasoning. And typically you see this technique when you have like longer word problems that you need to reason your way through. So there's a couple data sets, one called GSM 8K, which is like grade school math 8K. There's another one just called math that have a ton of math word problems. And so a one-shot chain of prompt thought, maybe you give the word problem and then you give an example to the model of you working your way through the word problem. And then you give the next word problem, and hopefully it works its way through step by step the problem itself. You can also just do zero shot chain of thought reasoning. You might remember a paper back, I forget when it came out, but I think it was called Let's Think Step by Step. And there's a few iteration or a few different iterations of this prompt that people have tried. There's just like the basic, let's think step by step. There's the let's work this out step by step and make sure we have the right answer. There's first, let's think about this logically. And there's walk me through the context in manageable parts, step by step, summarizing and analyzing as we go. So these are all examples of zero shot chain of thought because we're not giving it any examples of working through the problem. We're just simply telling it to think step by step, and it'll start spitting out its thought process as it goes through. And models like GPT-4 have been trained to do this in their post-training. So they've seen a lot of examples of let's think by step. And even in the post-training data, they've had annotators go through and like work their way through a math word problem and solve it. So I thought it would be fun to compare all of these on a GSM 8K style data set. So I have a sample of GSM 8K here, and I have a few iterations of this. So the first one I wanted to try was just like no chain of thought at all. So just the prompt here, no, let's think step by step above it. Let's just put the raw word problem and see what the output is. What I thought was interesting was even with the raw prompt itself and without us telling GPT-4 to think step by step through the problem, you can see it's kind of been in the training data because it says, let's solve this problem step by step. And it starts listing out, you know, this word problem is Toulouse has twice as many sheep as Charleston. Charleston has 4 times as many sheep as Seattle, et cetera, et cetera. And it'll break down, okay, Seattle has 20 sheep and Charleston has 4 times as many sheep. And it'll walk through its process of solving this. So even with these like GPT-4 style models, less and less you're having to say, let's think through this step by step, because the model already inherently has been trained to do this.
Are
Just
you
make-
overriding the default system message?
Not for this one. This is just their system message that they have in GPT-4o.
Do you know if the system message includes instructions to think step by step?
That's a good question.
Because recently Anthropic released Claude's system message, and it was like very specific and very long. So I wonder if GPT has a similar.
I wouldn't doubt if they did. But that's a good question. I don't know if anybody in the crowd knows the answer to that.
I just know not to ask O1 to provide a reasoning trace, or you'll get a nasty email from OpenAI.
Oh,
Oh,
yeah,
really?
I've heard that too, because they don't want you mining the data.
Hmm.
Yeah.
Funny.
And then they hide the reasoning from you as well, from what I've heard. Like they don't show you all the tokens.
It's also annoying because you have to pay for them too. They charge you in the API. So it's like,
Yeah,
what?
totally. So what I did here is, so I took that no chain of thought, and then I, you know, it's really hard to like compare the response that they had in the data set with the labeled chain of thought to the prediction that came out of the model, because it's not a direct string match there. So I wrote this prompt just to do like LLM as a judge and compare answer 1 to answer 2, and then just output true or false based off of that. And I thought it'd be interesting to look at the accuracy of this. This is, again, just 100 rows, just so I could do this in a reasonable amount of time. But just with the prompt and no, let's think step by step with GPT-4o, it got 96 out of the 100 correct. And so I thought it'd be interesting to look at the 4 that it got wrong. This one was an interesting one because it was Josh decides to flip a house. He buys the house for 80,000, and then he puts 50,000 in for repairs. This increased the value of the house by 150%. How much profit did he make? And I guess my little thing is covering the reasoning that they had there, so I'll move myself over here. And so the correct answer is 70,000, and the model said 195,000. So it got something wrong in the process here, but the fact that it's spitting out the chain of thought reasoning means that you can always go back and debug kind of like where it got wrong. But scary to think of if you're trying to use this in like a real financial analyst setting, even though it gets 96% accuracy on this grade school math test, it is not always correct. So there's definitely room for improvement. And this kind of got me thinking. I did try a few different variations of those 4 prompts that we talked about before, like let's think step by step, let's work this out to make sure we have the right answer. First, let's think about this logically. And they were all getting around like 80 or 95 to 99% accuracy. And I was like, huh, that's interesting. I wonder if we're just overfitting to this benchmark, because GSM 8K has been out there for a pretty long time. So I decided to write a prompt that would rewrite all of the questions and change the amounts and change the people's names. And so let's see if we can find Yeah, here we go. This is that same example. And so I wrote this prompt that would rewrite each one of them. And you can see instead of that first one, now we have Lucas is doing the thing and there is flipping his house. And there's different quantities and different valuations. And I literally sat there last night and did the math myself as I went through. So we might have to check some of my math. But what was interesting was when I changed all the people, all the places, and all the numeric values, granted, this is only 12 rows of data. It got 1, 2, 3, 4, 5, 6 out of 12 right this time versus the 95%. So that leads me to think these things are super overfit on the GSM 8K benchmark. And I think this would be a really interesting new data set. Granted, it takes a pretty long time to go through and do the reasoning and get to the answer yourself. These 12 probably took me like 20 minutes or so. But I thought that was super interesting that we went to like 50% accuracy on this very small subset. And I feel like we're overfitting to the benchmarks pretty hardcore.
Probably at least a year ago now, there was this really snarky paper written, and the title was like "Training on the Test Set is all you need."
Yeah. Was that the Phi team? Microsoft Phi?
No, that was textbooks are all you need.
Oh, textbooks.
No, this one was pure snark.
That's funny.
It was pretty good.
Yeah, and I could totally see how the test set accidentally leaks into the training set, especially once you're doing web crawls, and like it'd be hard to filter that out. But it was relatively straightforward to write a prompt to like rephrase all of these problems. The hard part was actually solving them, and you can't really use an LLM for that step because, as we saw here, it only got like 50% accuracy.
This doesn't apply to zero shot, but it's interesting to me how things like telling the model take a deep breath helps.
Interesting.
Greg,
Yeah.
this kind of reminds me of that test question that I had that I guessed on, which was, why would you repeatedly supply a user message or a system message with no user message contained? So blank out all the user messages. And the answer was to detect inherent bias in the model.
Oh,
So there were
yeah.
two answers. One was to gauge model performance. Well, there were four answers, but the two were clearly wrong. And then the two that I was trying to decide on was to gauge model performance, and then the correct one, which was more specific, which I went with just because it was longer, was to detect inherent bias in the model. So you just you blank out the specific parts and you see what it, without any specific user data, what would it reply with? It makes me think, like, for here, what would, if you blanked out all the numbers, or if you just, what would it would it show what would it drift to? Like, if, and it might show errors in your data set, or like if you're not properly randomizing the data set, like what you said when I rejoined at the beginning, like if you have too many negative models at the beginning, or negative sentiments at the beginning and versus positive, it would bias towards negative. It might, no system message might show that. It's kind of interesting.
I wonder if you blanked out all of the numbers but kept like the names the same, if it spits out the thing that it's overfit to. That would be a fun experiment.
That's exact. You just said what I said in a lot more words. Yeah.
No, yeah, I think that's a great idea.
Well, it was a test question, which I thought was dumb at the time, but now I think it's, I apologize to the test writer. That was a good test question.
A good one. Nice. While we're here, maybe let's go and see if that financial sentiment one.
It's done, and it's very verbose.
Is it? Okay, let's go.
Very verbose.
Take a look. Oh, that is funny. So we probably have to rerun this with answer with a single word, all lowercase. I was wondering why that was taking so long to run. Probably because it was spitting out all these tokens here. So let's try this again. Okay, this looks like it's being much shorter.
This
Cool.
interface doesn't have any support for structured outputs, does it?
Not yet, but that's something we're thinking about. What would you want to put the structured outputs kind of like in separate columns or just
Yeah.
like in one column as a JSON blob?
Separate columns or one column? I actually don't understand what you're asking. Sorry.
Oh, so if you had structured output that you wanted to have like two fields within the structured output, would you want two separate columns for each one of those fields?
Oh, like how would you flatten them?
Yeah.
To automatically parse it into the categories, Greg?
I don't know. That's a good question.
Yeah.
Yeah, because
Okay.
sometimes the nesting there's a lot of nesting, and sometimes the logic there isn't like trivial.
Right. Yeah. We'll think about it. If you have any ideas, let me know, because I think that would be super super helpful to provide a schema for the output that you want.
You know, Greg, you know where else that would be interesting is in double checking taxonomies. Like, so I feel like I'm the only person in the world, like on X, who thinks in an industry specific way, because everyone else there seems to be like an entrepreneur doing something one to many. But like when you care about your industry's taxonomy, like and Nicolay, you know Nicolay,
Yeah.
he had someone on that had a podcast guest on that specifically talked about this, and I almost fell over backwards because um I've never heard it described in how you can like analyze a data set and come up with a taxonomy, an industry specific taxonomy from a data set, and why that's important. And it seems like, so I'm just kind of talking about this because what you're saying now in terms of who was that guy that suggested it just now, but um showing structured results could help with that.
Yep. Yep. And I know even some of I think some of the newer structured output, or I forget what they call it, but they even allow you to provide like an enum of valid values, not only valid keys for the structured output. So that would be really helpful in a taxonomy sense.
Interesting.
Yeah, Gemini and Claude, you can do that. Or sorry, not Claude, GPT. Claude, you cannot.
Cool. Yeah, those are all it's funny, even when I think through those examples, I'm like, it almost feels like you're using an LLM as a power tool when you should just be using a smaller like BERT model or something like that if you're doing if you're just doing classification. But I totally get how it's way easier just to use the same LLM for everything. It feels like you're using a really expensive model to do classification. Cool. So yeah, that was a fun little, that was a rabbit hole I was going down last night of like solving chain of thought reasoning problems for myself. Which was this rewritten branch that I was doing here. Took me back to my grade school math days, and I had to work through some of these problems step by step, and it gave me appreciation for this technique. Cool. The other thing I thought about as I was going through this GSM overfitting thought experiment is I was like, I wonder what all the different models are getting on the math benchmarks. And you can see there's GSM 8K, which is this grade school math one. And pretty much all the state-of-the-art models get in like the 96 to like an A if you're a student, I guess. But then there's this other math benchmark that looks like it's a little harder. And this kind of lines up with my thinking here is I feel like we've just overfit to this one. And since we have a new benchmark, the models just haven't seen it yet. So I really don't think they're that great at reasoning yet. I feel like we're doing a lot of overfitting here. And you can even see they're using like 8-shot chain of thought when you're reading these things. I think it's nice to map these to the techniques that we talked about before. All right, I have like 10 more minutes, so we'll get through as much of the chain of thought as we can. So the next category within the taxonomy is few shot chain of thought. So we talked about like single shot chain of thought like this. Few shot would be you put a few examples instead of one. And then there's this interesting contrastive chain of thought prompting as well. There's a whole paper on this, but example of this would be you want to give the model an example of a valid chain of thought explanation. So this is doing the math properly, and then you can give it a wrong explanation, and you kind of say the category is wrong explanation here, and you mess up the math in this one, and then you give it the actual question, and then you prompt it to give you a valid explanation, and they say that this helped with the performance if you gave it some positive and negative examples of chain of thought reasoning, which isn't super intuitive to me when you think about how this affects the model, but they said that it worked, which I thought was interesting. There's another one called uncertainty routed chain of thought prompting. This is similar to the ensembling techniques that are later in the paper, but they say that you sample multiple reasoning paths and then select the majority response. So you could even take like all 4 of these prompts here, and it would generate 4 different responses. And then if 3 of them agreed or 4 of them agreed, you could assume that's the right answer. And maybe if they all disagreed, then you just respond with, I don't know. And this was proposed in the Google Gemini technical report. They used it more to like collect the pre-training data so that they could have some higher accuracy chain of thought. So when you think of synthetic data generation or like the fine-tuning steps afterwards, I think a lot of these more expensive techniques, like running the model 4 times, aggregating the results, and putting them all together, are totally viable in like a training data collection use case where they might not be as viable in a production setting, because you would have 4 times the cost if you had 4 examples, and if you did them sequentially, it would take 4 times as long. But thought that was interesting that in the Gemini report, they talk about chain of thought, but more in the training data curation half of things.
It would also help your model itself with like a built-in ranking, re-ranking capability.
Interesting. So you're saying you would like train on the outputs and say these ones are better than those ones?
Just give it all 4 answers in every one of those attempts, and yeah, train it to pick the best of the 4.
Yep, makes sense. All right, we're finally to category number 4, which was decomposition. We have 4 through 6 that we're definitely not going to get all the way through, but let's see as far as we can get. Decomposition is breaking down the problem into simpler subproblems. So it's hard to taxonomize all of these prompting techniques, because I also feel like chain of thought, you're breaking down into simpler subproblems. But I guess decomposition is doing it more explicitly. And the first one that they talk about is least to most prompting. So first you have the model generate sub-questions based off of the question, and then you make subsequent calls to the LLM to answer the sub questions one by one. And then once you have answers to all the sub questions, you can put that all into a single prompt that is the chain of thought reasoning and have it answer the question. So again, I feel like this is a more expensive technique, but could be great for synthetic data or training data.
Why is calling the model additional times necessary? Couldn't you do this in one call?
You could. So you would say like have the model generate the sub questions and answer them all in that same prompt.
Yeah. You would say
Yeah.
first generate all the questions, then answer each question one by one.
Right. Yeah, you could totally do it in one call too. I think I was thinking, yeah, I think you could do it either way.
I'd be curious to see how that affects accuracy for the sub questions, because if you have them one by one, there are no distractors.
True. Yeah, maybe it's like a focus thing for the model.
It's unaware, they're unaware of the answers to other questions.
Right. So that could be a good thing or it could be a bad thing, I think.
Yeah.
Interesting. That would be a fun experiment to run. Let's see. The next one was decomposed prompting with tools. So this one's similar to the other one, but you may need external tools to solve the problem. So in order to get the LLM to use the tools, it says you use few shot examples of using certain tools. And so like the decomposition in this context is decomposing which tools are available through few shot examples of the tools, and then having the LLM try to decide which ones to use. So this one is a little more manually decomposing because you have to give it few shot examples of each tool. But I think
Greg, what would be an example of a tool that it would be?
A tool might be like a calculator, if it just sees 3 times 15 and you don't want the model to do that
Oh,
calculation itself,
totally.
or a web search. So like if it doesn't know the answer, it could go do a web search, collect a bunch of like in context data.
Grab
Cool.
weather for Dublin from an API.
Yep.
Did you try this, the one?
No, I haven't tried this. And I know there's a variety of models that support function calling. But we haven't baked that into Oxen yet, and I haven't quite tried it in production. Is anybody using tools in their LLMs that's on the call?
I don't think he's here, but Aiden Quantum Cat does a lot of agentic stuff. So
Cool.
I
Yeah.
would imagine there are lots of tools involved.
And for the longest time, I was trying to everybody's talking about agents versus LLMs versus, there's a lot of different techniques here. And just the mental model that I have is like, is it an agent or is it just an LLM? It's an agent if it makes a call to an external tool. And that was also how they defined it in this paper. So when you hear people talk agents, just think like they parse the problem and then make an external function call or API call to get more information.
Greg, if it helps, there was a hackathon, I believe 2 weeks ago, where I did use a function call to call Code Carbon API. I guess we spoke about this project a while ago, so I get what you're talking about in terms of LLMs versus agents.
Yeah, totally.
Yeah.
Cool. Maybe if you come to the water cooler next week, we could talk more about that too. Sounds
All
interesting.
right. All right.
Cool.
Just one more quick thing on tool use. It kind of blows my mind that nobody has just like, I understand not using, say, SERP API or Google API directly or whatever, and building that into your model, because that would get expensive real fast. But like DuckDuckGo is free, and they have packages for several different languages, and so it seems like a no-brainer to me to just incorporate that into the model from the beginning. Let it ground its own answers, that sort of thing.
Yeah, I agree. I think there's a company here in town called Miroscope they're doing like a LangChain type competitor, and I saw him using the DuckDuckGo API in their repository. I would check that out. Miroscope. Oh, he named it after a miroscope because it's just like a very thin layer over the LLM. LLM extractions that aren't that don't get in your way. But yeah, I would check out this library if you guys want to.
Abstractions that aren't obstructions.
I love it. Cool. Well, we're about time here. I would love to go over the other ones in a later dive. But also that UI that we were showing here of the prompt engineering directly in Oxen. If you guys want to try that out, it's like an early beta. We literally rolled it out to prod like 5 minutes before the call. So I'm glad all the demos went pretty smoothly there. But hit me up if you want like some free credits to try that out, because we're just trying to get user feedback right now. So
Give us some free credits. I loved your demo. It was great. Yeah. So
you guys got it.
you
Hit me
guys
up in
got
the
it. We love
Discord.
it. We love
Yeah.
it.
All right. Thanks, guys. Happy Friday. We'll see you next week for the water cooler.
Happy Friday. Thanks, Greg.